I am sure that each of you, like when typing something in the search engine, you see that the retrieval is quite different and you look for something else, or sometimes you type the first word and you get the necessary results straight away. And our next speaker will tell you why. Andrei Raigorodskii, a director at Applied Mathematics and Informatics School, PhD and doctor in physics and mathematics, MIPT. He will tell us how mathematic methods can help the search engine produce the most relevant retrievals for users. A very good day, dear friends. I am so pleased to greet you, and I'm eager to tell you about the wonderful science. I want to convince you that mathematics is brilliant because it has a lot of applications. No, the applications may make it brilliant. I'll tell you about a great deal of very many applications. Practical things. I'll tell you about the AI in search. I'll tell you what the search is, and we also have graphs in the title of my presentation. What on earth could that mean? Probably not all of you know that. But let me move to the gist of my presentation. So some background information about me and our Applied Mathematics and Informatics school that I had. I'm principal of that, and I'll tell you about an application of the AI that is related to search, online search. You know that there are lots of search engines like Yandex, which is wonderful. We also have Google and other search systems, but how they operate, this is the question. Probably a person looking for something for you. You just type in a query, and somewhere there is a center with an army of people that would give you the retrievals. and I hope that definitely that is perceived as a joke by you, and you are much more literate, and you know that the AI is behind. It's about machine learning. Well, it's about ranking sites to match your query. The machine is to guess what you're after, which would be the top retrievals, which would be next, and what is spam and should not be displayed to you. And those spammers, they're optimizers, they're boosters, or probably they're good people, depending on your perspective. It is, you know, the battle between the armor and the gun. The more powerful the gun is, the thicker the armor. So ranking is displayed in the website. Let's browse for our Applied Mathematics and Informatics school, and Yandex gives, it is #1 in retrieval. It is the website of our school, with many other observations following this position #1. So in tens of billions of websites, the machine, guided by some rules or some inherent understanding, has been able to rank the sites properly and present the necessary sequence with the top retrieval matching our needs, and at the bottom there are some spam sites. How is that accomplished? Let's move to the next slide. Don't read it thoroughly. It is horrible. I'll just comment and say what it is all about. Well, the point is that when we want to train a machine, a big computer that ranges and ranks pages and results during the search, we invent a machine learning formula. We optimize the the understanding by the machine, inventing features or factors that are attributed to each of the pages on the internet. Like we have 10 billion pages on the internet, and each of these pages may have just some numbers, the natural numbers that we attribute to them. You may characterize pages by their content. You know, cracking a joke, I'll cite to you random examples. You can count the number of nouns on the page that we want to attribute, or the number of adjectives, or the syntactical signs, or some more complex characteristics, the text parameters, or obscene words or grammatic errors, like obscene language, and curses may also be rendered as a feature for ranking. You know, there are some emotional points either, but my mathematical stance at today's lecture is about graphs, so which will be the focus of my today's presentation, and it is in the title of the presentation, and many Russian-speaking viewers probably have thought that I'm going to tell you about noble titles, because a graph in Russian is like a count, can be translated as count into English. Homophones these are, and most of you probably know that in mathematics we have an entity that is called graphs. If we speak about the origin of this word, probably that is akin to graphics.
So a graph is a kind of image of a geometric structure of an object that we deal with. So in this case, we deal with the internet, and it's easy to understand, and soon we will do it, that the internet is actually a graph. If you initially know what graph is, further slides will get you at understanding that, and you will understand that graph is a simple object that can give you various significant themes that will help you build values that would differ the quality of ranking depending on whether they are relevant or irrelevant to your search query. So that is the main agenda of ours. So let's have a look at what kind of graph we are going to talk about and what graph is the base of the internet. We all know that the internet has a lot of websites. For example, here you can see the website of our search engine Yandex and the website of Wikipedia that can save us when we fail to know something. But I believe that at MIPT you will get a better education and better learning than Wikipedia. And the third website belongs to EAT, that is Moscow Institute of Physical and Technology, and Caucasus Mathematical Center is present on this slide that we actually actively cooperate with, and I had it. So there are these websites like this, and what do they have to do with graphs? By the way, you have pictures, images here, so we can see graphs in these images. If you have a look at this red image, Caucasus Mathematical Center, there is a tree with dots and lines, and we will soon learn that that is an example of graphs, but we will learn it a bit later when we consider graphs that turn up in the internet. Let's move on. we all know that there are hyperlinks to websites. When something is highlighted in blue and you click it and go to another website. For example, if there is Wikipedia, there are multiple hyperlinks because they link to their own web pages about different objects. Leo Tolstoy, Artificial Intelligence, Moscow Institute of Physical and Technology, maths, your humble servant. So really great number of pages, around 10 million. There can be hyperlinks that will take you not from Wikipedia, but from MIPT website. There will be around 1,000 pages that the links will go to, so the hyperlinks are not that many. And here you can see web pages connected with AI. But where is the maths here? So when do we have these graphs? Let's start drawing them, and it will gradually turn up. For example, here you can see a page that reads how I represent ICPC, Olympics championship that has recently been held on programming, and there is a hyperlink that will take you to another website. So you can see this arrow, and that is the same picture, but from a little bit different perspective. That is our conference on the left-hand side, and it will take you to another web page from Raigorodskii that will talk about some space vehicle that got down to in the Atlantic. So that is this hyperlink, and it has hyperlinks to other websites. And surfing the internet like this, we can even go to the NASA website. So when I have a real audience, I ask school kids, do you know what NASA is? Many say that, yes, we know that is the US Space Agency. And here we have a new arrow, then we just change the position in space, but the left-hand side is the same. MIPT with this press conference, then Raigorodskii with the spacecraft, and then NASA, and then USA government website that another hyperlink takes us to. From that, we are taken by another hyperlink to the White House, and so on and so forth. So these hyperlinks can be mutual, by the way. So web pages that are located on one website can quote web pages that are located in another website, and then we will have these two-directional arrows. That is something that can turn up. And furthermore, there can be arrows, several arrows that are going in the same direction. Even this can happen. And even more awesome, there can be this kind of loops. So there is an arrow from the website on itself. So one web page of one website can quote another web page of the same website. Therefore, we will receive this kind of loop. Let's go beyond this picture to see how a real graph turns up. Let us just replace every website that we see as a single document now with orange circles. So you see the structure is the same, but without the images that specific website and web pages have. And this is the structure that is called a web graph. Web graph. Well, we all know that web is net, right? World Wide Web. That is the internet, net, right? And that is the graph that turns up from the internet, and that is a very important object, studying whose qualities we can improve the quality of the search and rank different documents according to your search query. Talking about it in a more general way, a graph is not necessarily a web graph. That is any similar structure. So in this case, it is shown in circles, but usually these are just dots on space, and these dots are called peaks of graphs, and the arrows are usually called the sides of the graph. And if when you do not even know where this picture comes from, and you do not see these orange circles, it can sound really bizarre. Leo Tolstoy, is he a graph? Well, definitely he has sides, well, had sides, or he has peaks and pinnacles in his creative work. But no, graphs, there are the different things. So there are these pinnacles and ribs, sides or ribs of graphs. Graphs can appear differently in nature and society. For example, there are millions of listeners now listening to this story about graphs and their help to AI. It's clear that some of these listeners know each other, whereas others do not. And again, a graph turns up because the pinnacle of this graph are you, my listeners. Every person is an abstract circle, and two circles are connected with an arrow if these two people know each other. So that is a pretty natural graph, social network, if you wish. This slide shows you an image from the internet that depicts how powerful and rich a web graph is. This is this little part of it, and here is a huge, powerful internet with dozens of billions of websites and web pages. And this slide shows us that we can meet graphs in nature very often, and it's critical to work with them, to be able to work with them. And that is a truly beautiful story. I adore talking about graphs, and I have some special lessons that are devoted to it. You can follow that. And at Physics and Technical Institute, I will by all means talk about that to you in abundance. You remember features that we can use as assistance to artificial intelligence that deals with ranking by search query, right? That is all really interesting to study. Here we can see another very nice graph, and I truly am willing to show it to you. It is bi-lobed graph. There are scholarly chairs and industrial partners, and they join together when they start interacting at MIPT platforms. I will not go deeper here, but that is again a pretty graph story, serious one. Let's start with the easiest that we can think of in the world. The easiest are the degrees of graph pinnacles. Let us take this fish graph with, you see, the head and the tail, and let's determine what these graph pinnacles or nodes are. So the ribs are not arrows, but just lines of blue that join some graph nodes or points. And that is an example of a graph, just for us to give a definition. So the degree of the graph nodes is just the number of ribs that are joined to it that have this node as its end. Well, you can say that it is much more complicated in the internet because there are outgoing ribs. So there are arrows that proceed from the node, and there are incoming ribs that go to this graph point, and they are different in nature. Very often when we study the internet, we have a look only at the incoming links because they are likely to characterize this or that website more. So if you assign a degree, so the number of other sites, websites to this one, you will receive this ranking. And that is something that you can do with the help of machine learning, and that is a separate story. But this factor, this feature, is not difficult actually to increase. You can ask your friends to have links to yourself, or you can do it even in a worse manner. You can pay to some link vendors, and that will kind of cheat the search engine because it will believe that it is a very good website because of a lot of because it is cited a lot, but well, it is not so, so it's not truly legal, and very fast it stops working. A more interesting feature is centrality. Between the centrality, and I will give you just one definition. No one knows how to translate it best into the Russian language. That's why it exists in English only. So it is called between centrality. So the definition is here. That is the share of shortcuts that go through a certain graph points, graph pinnacles. I will now show it to you on this picture. Let us consider this D point that is highlighted orange, and then have a look at some points, pairs that are different from D. For example, in the orange circles, we here have A and E points. So let's have a look at them, and what would we try to understand? What are the shortest paths between A and E? It might sound too abstract, but can you imagine this navigation on the internet through hyperlinks? That will be about that. What is the fastest way from one website to another? I don't know whether it is in social links or political. Very often there is a story about bourgeois medieval family that turned out to be the most influential ones, because as for other two families that wanted to trade between each other, found that it was the best way for them to do so through bourgeois. So the shortest paths between A and E, here is the first option. You can go from A to E through B and D. What is the fastest? Well, equally fast will be through C, but again you will go through D. So you will go through D in any way, and any other paths from A to E are longer. Naturally, you can go from A to B, from B to C, but that will be more paths, longer way, and that is less convenient. It turns out that both shortest paths that join A and D go through D. So the shares of shortest paths from A to E, that goes through D, equals 1. Out of those shortest paths that we have, both go through D. That means that the share is 100%. So D is a very influential point, and you cannot bypass it if you want to go from A to E in the shortest path. Let us have this between a centrality for D equaling 9. And as for what I've said, it is also true for all other options. D is an inevitable point if you want to have a shortest path. And anyway, the share is 1, and if we combine all those shares, that is 9. And that is what is called betweenness centrality. And that is very similar to the Bourget story. But if we look for the same share of shortest paths that goes through B point, the picture will be different, because if we go from A to G, here we have a long shortest path that has 4 ribs, and it can go without B, and here it goes through B, so it can go like this and like this, right? Like this and like this. In one case, it goes through B, in another, it avoids it. So the share of the shortest paths here equals half, right? So that is less influential point. And if we look at all other point pairs, then the sum that we will have will be like this. So the influence for B will equal 2, whereas for D it equals 9. And let's now move to the degrees of point centrality, degrees versus centrality. So if we have values in the first case, that is like this, and in the second case, it is like this. So ranking is different. So step by step, I'm getting at turbulence. That part of the lecture that might be clear to the selected only, but I always talk about it because I want the listeners to be impressed and to be incentivized. But on the other hand, I really need to show you certain future, come up with a catharsis so that you can understand that if you really learn maths well, then you would be able to work with AI much better than if you just work out of what you know. That's why I would like to show you this definition that might not be clear to you now, but that is like for the future. So that is a feature that is even better than degrees of points, graph points, or centrality. That is so-called page rank. I'm sure that you have heard this word, but I will not go into detail here. Just have a look at the hieroglyphics and enjoy them. The sense is as follows. We want the quality, so the values that are assigned to each point dependent on the quality of the points that link to this point, and it is P with E index, and it is composed of correctly divided by something qualities of P with G index, and under the sign sigma we have J arrow I, and it means that we have a look at the quality of each of the points, combine them, add them to each other, and thus we should have the quality of the graph points and that is the system of equations, and the founders of Google actually invented that, and Google is prosperous for this, thanks to this invention to many extents. And now definitely they need to come up with some other wiser factors and more interesting math stories, and that is real graph modeling. That is the so-called Backland-Osgood model that enables us to describe the features of the internet. It is probabilistic, and there can come random graphs that are highly likely to be similar to others, and that it enables us to improve crawlings and quality of search. It helps look for spam, find breaking news, as they call it in the US. But that is a separate, immensely interesting thing that we can devote a separate lecture to, and I like doing that. And you can even find some videos of that. To conclude, I would like to say that our faculty of applied IT and maths, we have really very powerful AI research, and here you can see some websites that would be interesting to school kids or students. That is like online masters, and by the way, that is in English. So if there are English speakers listening to us now, that is something that you can actually study at. And there is deep learning school as well, and there is also professional development, and there is also bachelor's degree program in English, computer science, and there is also advanced combinatorics and graphs is a separate section there that you can devote your time and life to for the sake of the beauty of maths. So, dear friends, thank you very much for your attention. Love maths.